Geologists from Yellowstone National Park were performing routine maintenance at a temperature recording station in Norris Geyser Basin, their first visit to the area since the previous fall. When, to their surprise, they discovered a new blue spring, identical to the one they had seen last year. The new pool they discovered was located in the porcelain subbasin of Norris Geyser Basin, just west of a patch of vegetation informally known as Tree Island. It was about 4 meters, 13 feet wide, and the water in the pool was warm, about 43 degrees Celsius or 109 degrees Fahrenheit, light blue, and about 30 centimeters, 1 foot below the rim. They said nothing and got right to work, as this was a job they weren't going to shy away from. The geologists discovered that the pool was surrounded by numerous small rocks, up to 30 centimeters, about 1 foot, in diameter, and the rocks themselves were covered in fine-grained, light gray sandy mud. There also appeared to be 2 layers exposed on the sides of the pool, but the lower layer was simply the layer left on the steep side of the pool when the water was at a higher level. With all this evidence of considerable disturbance, they knew they had found a hydrothermal vent. The possibility of a hydrothermal vent in the Norris Geyser Basin is not surprising, given that the thermal basin has been the site of numerous similar events. Some, like the crater in the Gap subbasin, likely occurred before anyone documented the area, and their age is unknown. The Pork Chop Geyser explosion of 1,989, for example, is well monitored. Thanks to a new monitoring station installed in September 2023, these explosions can now be detected by geophysical data, including the explosion in the Porcelain Terrace area on the 15th of April, 2024, which left a crater several meters in diameter. One tool that can be used to investigate thermal changes in Yellowstone is high-resolution satellite imagery. While this data is not useful at night or on cloudy days, cloud-free daytime satellite imagery provides excellent views of the land surface. Satellite data indicate that no features existed on the west side of Tree Island before the 19th of December, 2024. By the 6th of January, 2025, a small depression had formed in the area. Satellite imagery from the 13th of February, 2025, shows a pool of water, indicating that the feature had fully formed by that time. Another useful tool for assessing hydrothermal activity in the Norris Geyser Basin is a new monitoring station installed in September 2023. This station uses infrasound low-frequency acoustic energy to detect hydrothermal activity. The infrasound array can not only hear eruptions, but also determine the direction of the sound. Interestingly, there were no strong, clear eruption signals during the period when satellite imagery showed the feature forming. However, there were several low-level acoustic signals emanating from the direction of the new feature. The clearest signal was recorded on the 25th of December, 2024, but it was relatively weak, and there was no associated seismic signal, something that is common in large eruptions. Similar acoustic signals were recorded on the 15th of January and the 11th of February, 2025, but again, there was no seismic signal. These new thermal features did not form in a single large eruptive event, such as the one on the 15th of April, 2025 in Norris Geyser Basin, or the well-observed event on the 23rd of July, 2024 in Biscuit Basin near Old Faithful. Instead, these thermal features appear to have formed through several smaller events that initially ejected rock and then ejected siliceous mud over short distances, creating small cavities that later filled with silica-rich water. The new thermal features in Norris Geyser Basin, perhaps the most dynamic area in Yellowstone National Park, show a spectrum of hydrothermal feature evolution, some formed in brief, violent episodes of change.